Good morning, sir. Uh, for this presentation, we will be presenting on the Amazing Lunch Indicator app and its functional analysis. Together with that, we'll also be discussing about test automation tools, its analysis and demonstration. So to begin with, the functional point procedure was first we had to find the external inputs, outputs, internal logical files, external interface files, and external inquiries. We had to determine it. We determined this using the UI that was given in the SRS document, as well as the requirements that was given as well. Using that for each internal and logical file and external interface file, the record element type and the data element type was determined or needed to be determined. This was determined from the input and output of the lunch indicator app, highlighting the files that were accessed. And for each external input and external output and external inquiry, the file time reference and the data element type needed to be found. This was found from the app UI and requirements, which highlighted the files accessed and the data fields referenced. Moving on, all inputs, outputs, and queries from the data requirements showed unique data fields that the user uses to enter information, and potentially the files or the tables the records are stored in. It also shows data fields accessed for output to users. Data fields are the DETs, while the RETs are the logical grouping of DETs. For example, the user account will have multiple DETs under it, such as username, password, email, etc. And these are all grouped together as RETs, which is the logical clustering that defines it as user accounts. FRTs are basically the files that needs to be accessed, and then each file will have various DETs, basically independent data fields that's stored in that table or the file. Moving on, we first had to find the internal logical files. We had five main files: user accounts, owner information, restaurant type XML, and dish XML. So you'll see that RETs basically there's only one logical grouping of information that's associated most of it, except restaurant information, because restaurant information had information about the restaurant as well as the dish that was served in the restaurant. So that it has two RETs because it has two logical information that's being accessed, and the number of DETs are basically the independent fields that are accessed. And then using the table that's given below, based on the RETs and the DETs, the complexity can be determined. For most of them, the complexity was low, and then the total internal logical file complexity came out to be 5 in the low category. Moving on for external interface file, this is basically the files that is not managed or controlled by the organization or company, unlike the internal logical file, which is managed and controlled by the organization themselves. For this one, there is only one file that is being referenced that was beyond the company's or the app's scope, which was the GPS map information. There was no exact information given about the GPS information, so there was no RETs or DETs that was mentioned in the SRS, but we made the assumption that there would be one logical group regarding the map information, and then some of the independent fields that would be accessed would be the longitudes, latitudes, the current location of the person, the destination location, and the distance, etc. And using this information, uh, we measured if based on the RETs and the DETs, we determined that the complexity would be low. But if or there was more specific information given, they could have been uh, the complexity could have been higher. So the complexity for external interface file was 1. Moving on, for external input, this is basically all the input that the user makes into the system. So there was a lot of inputs from all the different users. So basically the normal user, the owners, the admins, they would all have their own boundary or their UI there, which they can use to enter information, and they will have certain number of fields where they can fill in, and then this will reference multiple files or logical groups. And then using all this information, we did using the file types that was referenced in the logical fields or the DETs that was basically used, we determined that the complexity, total complexity low would be 15 and average would be 5. And moving onwards, for external output, this is basically all the processing that the system has to do and provide it to the user through the, and then displayed on the user's UI. So for some of the ones that we identified was the retrieve password email, which would, and GPS map information, navigation, and owner verification email. So when the user wants to find or retrieve their email, only one file is being referenced, the user's file, and only their password, the independent field, which is password, is being accessed. For GPS map navigation, one file is being accessed, and then four particular information is being accessed, such as the destination address, the current location of the person address, the distance, time, or map information, etc. And then based on all this information, the file types that you reference in the DETs, the complexity came out to be low, which with a value of 3. For external inquiry, this is basically when the user tries to search something in the system, and this system retrieves and displays it for the user. There is no processing being done. It's only a read and fetch type of scenario. So basically, whenever the user wants to search for a restaurant or filter restaurant results, etc., then the user would make uh, using the fields that was present on the UI. He or she would enter all the information in those fields, and then or send the data or press on the filter button. Using this information, the number of FTRs or the files that was referenced and the number of logical groups that was referenced, you can use it and then determine the complexity. And then when the system actually has to go and fetch this data, they will they will go through two files, and then, or depending on how many files they have to access, and then how many information has to be retrieved or fields that has to be read and retrieved and displayed to the user. So there's two sets of uh, information that can be used to determine the complexity, one for input side and one for output side. And using the file types reference in the DETs, you could find the complexity for input side and output sides separately, but the final complexity for that particular record, let's say for search restaurant list view, the final complexity would be the one that's higher. So you will see that input is high and output is average, but the final one is high. And this was done for all, and then the final complexity was 3 average and 3 high. Moving on, each uh, each level of complexity has its own weighting. So for different uh, let's say for internal logical file, external interface file, external input, external output, etc., all of these have their own weighting. And then once the calculation was done, the final unadjusted function point was 147. And then moving onwards, you to calculate the adjusted function point, you have to first find the degree of influence, and then degree of influence defines the overall complexity of the system based on certain characteristics. So some of the characteristics, the general system characteristics, are data communication, distributed data processing, performance, and then the app itself prioritize some of these characteristics more over the other. For example, performance, it in the non-functional section of the SRS document, it said that it had to process the request in, I think, less than a second, and then for that reason the degree of complexity for it is the maximum with a value of 5. But there's other places, certain sections where complex processing, like mathematical and logical processing, that was low, because for most of the most of the features of the app, it's basically just doing crude functions basically. So storing data, reading data, updating data, etc. And then based on all the various information, the degree of influence for each characteristics were found, and there's 14 characteristics in total. The total degree of influence was 49, and using this information and these two formulas, the complexity adjustment factor was calculated, which was 1.13, and the adjusted function point, the final one, was 166. And then the purpose or the advantage of using function points in resource management is that FP can be used in effort, cost, and productivity estimation. Effort refers to the total amount of work done in terms of time to accomplish a task. If it takes 5 person hours to develop one FP and the lunch has 166 FP, the total effort of the project would be 130 person hours. Cost is how much finance is needed to finish the project. In this case, if the cost per hour is $10, then it's $8,300 for the total cost of the project. Productivity is the efficiency of the team to deliver a FP in certain or F in a certain effort. In this case, productivity would be 166 divided by 330, which is 0.2 FP per person hour. So productivity basically shows how much function or business, how much functionality of the system can the team deliver in a person hour that helps the business and represents the business logic. That was all, and now we'll be moving on to test case strategy and design.
Moving on to test case strategy and design. For the Amazing Lunch Indicator app, we use three strategies. Firstly, decision tables. Then we use scenario testing as well as equivalence partitioning. To further elaborate on decision tables, for the first interface, as seen here, the login screen, we looked at the conditions, or you could think of them as variables, and all the possible combination values for them. For example, for a username, you can have a correct password, a wrong password, or it could be invalid. And then the username field itself could be correct, blank, or incorrect. So for example, in this case, we have two variables, username and password. You have two possible combination, 2 to the power of 2 possible combinations, where you have a correct password and a correct username, and an invalid password and a correct username, or an invalid username and a correct password. And to further add on, is another value you could have would be null or blank fields. So you could have null or blank fields for username and password, and based on that, we look at, okay, what decision would the interface make? If you have a valid username and password, it should allow you to log in. If you have a valid username and a wrong password, make it should not allow you to log in and display an error message. So we've used this for other interfaces as shown in our report. The next strategy we used was equivalence partitioning. So if you given a form, you have a list of fields. You can have valid inputs for those. For example, you have valid search text. You have, for the field where the minimum destination, a valid input could be greater than 0. Same thing with price, it could be greater than or equal to 0. So you look at all the valid partitions for a particular field, and you test only one value within that valid partition field. So this reduces the number of test cases you have to run. So looking at this interface, we could identify 5 valid partitions and around 9 invalid partitions. This reduced the amount of test cases we had to run, as we could just check each value within these partitions. And lastly, we also did scenario testing. This is more of, okay, does the app or interface work like how it is supposed to in the real world. So it involves just looking at a particular component, using it how a user would normally interact with it in the real world, and seeing the expected result. As you can see, for example, the back button procedure, you press the back button, and the expected result is okay, the user is navigated to the previous page. And a precondition would be the user must already be on the page where the button is displayed at.
Bullock, I'll be talking on the tool that we use for this system. So we use Selenium, which is an automated testing tool to test the functionalities in the system. So we talk moving on to the core functionalities. Selenium basically uses web drivers uh, to like communicate with the browser. So basically, it injects that JavaScript into the browser to perform scenario-based testing. Like it uses test scripts to mimic user interactions with the web applications. So yeah, another functionality of Selenium is it allows logging and monitoring by taking screenshots for every testing process. So this allows us to see which part we made errors in. So I move towards the strengths. Strength of Selenium is like one of its strengths is it's open source. So it allows integrations with other testing frameworks such as JUnit. Another one is that it allows concurrent and distributed test script execution. And it's basically compatible with other programming languages like such as Java, Python, C Sharp, making it flexible for other development environments. Moving on towards the drawbacks, Selenium only works with web applications, not mobile apps and desktop applications. That's one of its limitations. And another one is that Selenium interacts with a web application and using element IDs, but if ID's element is dynamically changing, Selenium won't be able to find the element. Another drawback is that Selenium it it's not able to handle delays and timeouts automatically. So every step it has to like load the element. Of not, the test will fail. And that's basically all about Selenium. I'll be handing over the next slides to my team member to explain more on how we demo Selenium. Thank you.
Okay, over here we'll be doing the demo of the two main functionalities, which are writing test scripts that mimic the user interaction in the browser that uses Selenium web drivers, and the second functionality is after running each test script, so that each test cases in the test script, uh, it will be logged into the results will be logged into the screenshot through Selenium. So for them, we'll be testing this login page from our booking system, right? And this pattern file shown on the screen has one valid and four in it has one valid and three invalid test cases. And Selenium will run all of it, and the results will be logged into screenshot. So let me start the video. So after running this Python file, it uses Selenium WebDrivers that opens the browser and enters the URL automatically, and Selenium automatically inputs the data in the field and clicks the button and tests of every thing we have mentioned in our test script. So right now it's testing invalid test case where it inputs an email address and the password is kept null, and then it saves the results in the screenshot. So right now it's doing its thing. Alright, now this is done. Next, it will test another invalid test case where the email is kept blank and inputs the password, and the result is saved into the screenshot as well. Now let it do its thing. Alright, now it saved the results in the screenshot. Next, it will test another invalid test case where the email is correct, but the password is incorrect, and it saves the results to the screenshot as well. And the last one is a valid test case where both the email and the password is correct, and it saves the results in the screenshot. Alright, now it's doing the last test case. Alright, now this is a valid test case. Now let's open the console and see what happens. So let me extend this. Okay, now this console shows steps for each test case we have conducted using Selenium, and it shows what it did in each of the tests over here. Alright, now this is done. Now this is one of our invalid test case, which is the blank password. So this is a screenshot Selenium gave, and this is what we got, where it showed we inputted a correct email address and we gave a blank password, which is one of the invalid case, and Selenium tested out through its web drivers. Second one is blank email, where the email was kept blank and the password was given, and it was also invalid test case where the user could not log in. The third one this was the incorrect password, where the email address was correct but the password given was incorrect and the user could not log in, making it an invalid test case as well. And finally, this was a correct login, where we gave correct credentials and the user was able to log in. And yeah, that sums up our demo for that Selenium testing we had to do. Well, thank you for, well, this is all from our side. Thank you.